Hey guys, how you doing? Welcome back to another episode. Today we are going to solve this problem called design search autocomplete system, and this is a LeetCode hard problem. And the unique thing about this problem is that this problem is also only available on LeetCode Premium. So I think it would be a great feature, a great problem if you guys don't have the premium. If you have a look at this video, and it's quite complex problem. I feel that, and this video might be a bit long because we'll be diving a bit deep into implementation of this. So also this problem appeared in Google and Amazon and Apple and a few other companies. So this is a very top problem, and whenever we think about autocomplete systems, uh, we just think about Google naturally, right? So without further ado, let's jump into the problem, and we'll see that. So yeah, whenever we have to design an autocomplete system, the first data structure that comes to mind is a trie data structure, right? TRIE. So a trie data structure is like a very much like if we have three, if let's say we have ABC, AB D and ABB, right? Or let's say AB. So we design the tree in this manner. So from A we have first element as A, and from there we have a children called B, and from there we have children D and C, right? So you can think about a trie as a tree-like data structure where each node is one character. So, okay, so coming to this problem, so the problem statement goes like this: design a search autocomplete system for a search engine. Users may input a sentence, it's like at least one word or anything that ends with a special character hash. For each character that type except hash, you need to return the top three historical hot sentences that have prefix the same as the part of the sentence already typed. So it's very exactly similar to Google search engine box. So whenever we type something, we'll get to see the top three. In Google we don't see the top three, but here we, to make the problem much more doable, we have like much more smaller scale, we have made it they have made it top three. So top three, how would you get the top three? It would be, they have given a parameter called hot degree. So hot degree is the frequency of the word. So let's say so jumping into this example, you can read this problem later on, I think. um, so jumping into the example, so they are giving us a historical data. So let's say these are the four sentences they have given. It's I love you has been occurred 5 times, and island has occurred 3 times. I love LeetCode has occurred 2 times, and Iron Man has occurred 2 times. So when the person types inputs I, so as you can see, the words, all of these start with an I, but according to the hot sequence of this, according to the frequency of this, we have 5. I love you has a frequency of 5, and that's why it shows up at top. And then we have frequency of 3 for island, and that's why we have island in the result. And then you have we have a like a draw, a tie in Iron Man and I love LeetCode. But if we see the explanation, they say that since I are same for both of these, but you can see that the second character of Iron Man is R, whereas the second character of this I love LeetCode is a space. And lexicographically, space comes before an R because of the ASCII value, right? That's why they have given preference to this one. So we have to give preference to the hot sequence, that is the frequency of the word in the historical data. If whichever has occurred more number of times, you are going to show that in the top three results. And if they are same, in that case we have to return the lexicographically smaller earlier lower sentence, lower string. And otherwise, if we do not have enough enough sentences to show, if we do not have 3 sentences, we have to show at most how many we can, even if we can show 2 or 1, right? So that is the problem statement. And when the input is a special character, it means that the sentence ends, and in that case you need to return an empty list. So this is the condition where the sentence is ending with a hash or a special character, and we need to like return an empty list in that case. So if you see this input, it ends with a hash, that means the typing has ended, and we return an empty string in that case. Also, note that for every historical data, you have to enter the historical you have to enter the sentence entered in the historical data, right? So it's an object, and I need to populate that object every time someone types in a feature, because if I type in hello world today, and it should go into the system, into the historical data, so that next time if I type he, it would show me hello world, right? So you get the idea now. And I would suggest you guys to pause the video right now and give it this problem a shot if you think that you can solve this. Otherwise, let's start coding the solution. So what I would be using is I think a trie would be the best data structure to implement such kind of problems, and we would be creating a trie node. So I'll be coding in Python, as most of you have known me. So I code in Python in most of the videos. And also, yeah, this problem was recommended by one of my subscribers, so I'm solving that. So thanks to that subscriber. If you guys want me to solve problems, please do comment below, and I would definitely look into your comments and solve those problems. I would also give a shout out to you guys if you want a shout out. So if you are facing any difficulty in problems, any kind of problem, just give me the link to that problem. I'll definitely solve it for you. Okay, so I would create a trie node, and for a trie node what I need is so this is the constructor, right? And the trie node would have a children. So basically the children is okay, so I need a dictionary. So I would import from collections, import default dictionary. So what is the advantage of default dictionary? We know that you can just go up in the documentation and Google it somehow. Otherwise, I would just brief and short. So default dictionary is like exactly like a normal dictionary, just that if you do not have a key, it would return the null value or zero value based on how you initialize the dictionary. So that's an advantage, and it's a little bit optimized than normal dictionary. With a few more features. So I prefer using default dictionary if I want to make a hybrid data structure or something like that. Otherwise, if I just need to use the plain vanilla dictionary, I'll use normal dictionary using the curly braces and Python. Yeah, so I would create the children. So a trie node, oops. So a trie node would have the children, and the children would be what? A default dictionary of trie nodes, right? Because one trie node would point to another trie node. So in that case, you see, I am telling that this would be a trie node. So the default dictionary I am initializing with a trie node. So if I next time ask that give me self children of a, b, anything, let's say z, it would give me a blank trie node. It would give me a null trie node, right? Because it does not have anything. And if it does have something, it gives me that trie node exactly. So this is like the default value it would return. If you would have entered int, it would have returned the default value of int, that is 0, right? So that's an advantage of default dictionary. That's why we use it. Also, another thing that we um, need is we need to reference the dictionary exactly. So we need the count and various other functions. So I think we'll need the count. So but I'll do this later on. So okay, coming to the autocomplete system, we have to have a root from where we'll initialize the data structure. So that would be a trie node, right? And from there we'll have we need a constant iterator. So we'll use self.current or something that we are currently at. It is self.root for starting with it. So current is like an iterator, a pointer that points to the current node. And next what we need to do is we also need to keep track of how many what is the current sentence being typed. So I'll just call it buffer, or let's keep it simple, let's call it sentence, and it's empty for to begin with. And what I need to do is they have given us a list of sentences and we need to use them. So for for I in range, so basic for loop in Python, sentences, so they are giving us a historical sentences, and we need to add it to the sentences. We need to add it to the trie, to our autocomplete system. So we'll define a function called add later on, but for now I'm just abstracting that out. So let's say self.add, we will be adding sentences of I and how many times that has occurred, right? So the historical data, we are appending that, adding that. Now we need a adder. So def add, which we used here, self, the word or whatever you call it, let's say the string. It's not exactly a word, it can be a string also, and it can be a count. So this would add something to our like root, to our autocomplete try node. And so currently I'll be at root. Okay, so I need to iterate the entire try again. So what I would do is I'd iterate for each character in the string that is given to me. I would get the, like I would get the, I would basically iterate over the try node. So for each try node, I need to go down one character by character. So cur of children of ch, I need to get that. And if there is something, I would go there. And what I need to do is I need a counter as well. So what I need to do is I need a counter as well. So for each level I go down, I also need to add that this string was occurred this many times. So I would add a count, which is the default dictionary of int here. Why do I need that? Because let's say I add hello world, hello was there. I'm adding another character, I'm adding another word, basically hello. So the count of that should also be present with each. So I need a so in each of the try node I need the count, so that count can be accessed throughout my throughout the entire try data structure, right? So that's why I'm using a default dictionary of int. And what I would do, the trick I would do here is so cur is basically what, that next children. So cur of count, I would add that with, so cur of count, and this is a dictionary, so it would be that string, the entire string would be increasing with the count of that, right? So that's it. That's basically adding a data structure, adding an element. Next, what we need to do is basically input. So input is the main function that would be called every time. So what we gonna do is there can be two input, can be differentiated into two types. If each character, so the user gives in a character every time. So if the character is a hash character, so we know that's end of the string. If it's not a hash character, we return the top three. Okay, so if c is equals hash, if it's equals hash, so basically add that entire string, um, you know the sentence that we have till this time, we basically add this entire sentence, and the count would be incremented by 1, because that word occurs one more time. And we the cur value, that is the current value that we are iterating, the state would be the root, because next time when I enter something, it should start from the top of the try again, right? Because I am iterating the try for each time, each time an input happens, I am going one level down the try, because one character is inserted. So once there's a hash, I cannot go down anymore. So next time user enters anything again, I'll start again from the top. That's why I'm setting it to root. Okay. Cur is the current pointer in the try, current state, and I'll reset the sentence as well. So this is basically resetting. Okay, so I'm going to reset the sentence as well. And as they have asked us to do, when there's a hash, we just return it by empty list. Else, what if there is not a hash? Actually, we do not need an else because we are returning, but still let's keep it, it's easier to read. Else, that means we are entering a valid input. So first and foremost thing is we need to increment the sentence, that is a buffer, the buffer we are keeping, that is what, how much has been typed till now, right? So that is the value appending that with C current character. Okay, so we need to go to curve, would go to one level down. So self dot curve dot children of C, obviously. So we are going one level down, and what now? So we need to return the records basically, or the result, right? So how are we going to do that? Okay, so what we can do is, so we have self dot cur dot count, right? Okay, let's do something for string and the count in let's say self dot cur. So we are at this pointer, so this pointer has some values, this count values, and this is basically pointing to what are the, what are the other values at this point. So if I have typed h, hello has been occurred 3 times, hell has occurred 2 times, and hey hi has occurred, or okay, it's a word, so hey has occurred, no, it can be sentence as well, it's like hey hi has occurred any number one time. So that's why we need this loop. um, so we are going to iterate over that, and over the items of that. So essentially it's itself. So um, we actually don't need the items. Okay, fine, let's keep it for now, we'll remove it and see. And what we need is a heap data structure here, because we are looking for top 3, so we are creating a heap data structure, and top 3 we need. So we need results, and all the records we have. Okay, so what we're gonna do is first we have to import heap queue. um, so Python has this heap queue import star, so we are going to import heap queue, and we are going to heap push. So basically this records is a heap, so I'll just make it records heap for easier understanding. Into this record heap I would insert my current, whatever I'm iterating, right? So what is important to me, it's a max heap, and that's why Python has min heap. So we'll enter minus count, because count is my first priority, that is a hot key, hot word, hot frequency, whatever, and minus count, and then the string, because if they are lexicographically, if they are same hot frequency, in that case we have to get the lexicographically maximum, like the lexicographically which one is maximum, right? Earlier one basically. So that's how we initialize this heap, so for all the items. And next what we do is for I in range 3, because we need the top 3 elements, so we need 3 elements. Basically if records dot heap is still there, I just need to, like, it's basically okay, so what did we append in this heap? It's this count and this string. So this count and string we're going to pull out from the heap, right? um, Heap pop we are going to do, and we are going to pull out from the heap, so record heap. Okay, it's, we are doing it until the length is greater than 0. So if there is something in the heap, then only we'll do that, right? And what we are doing, we don't need the count, we just need to add this to our results. We need to add the string to the results, whatever string we get in our results, and that's it finally, because we can return something. so we can return results from here. Also, we don't probably need the items. um, yes, we don't need the items also. So let's try running this. I think that we might get some bugs, so we might get some issues, but let's see if I'm lucky enough to get this correct. Okay. uh, no, yeah, correct, I was correct previously, because we are unpacking this st and c and the count string and the count, so we need items. What we can do is something like this. If you don't want items, count equals self dot cur dot count dot string, like that you can do, but that's like typing so much unnecessarily. That's why. Oh wow, we are getting an accepted here. So I would just use items, it's much more clean, because we are iterating the entire dictionary, right? Iterating all the values that can be found after from that much type string. So we are getting correct results, seems like that. So let us try submitting that, and I'll try submitting this. Let's see what we get. um, Great, so we got all correct, we got the solution accepted, and this one is a pretty good problem, guys. So here's my solution, you can have a look at it. So I'm just scrolling it once again, you can have a look at it and understand the solution. If you guys have any problem, just write down in the comment section below. I would be happy to resolve it for you. Also, thanks for watching this video for so long. I think this was a bit long video, but I think this was pretty much difficult problem, a hard problem to solve. And all the best for your interview, guys. Hope you enjoyed this channel, and do let me know in the comment section if you want me to solve any problem for you. I would definitely love to solve and explain that. So till next time, have a great day. Happy interviewing.